Hello and welcome to Woodsstation. Today we're going to be talking about lenses. So there are two types of lenses. There is a converging lens and a diverging lens. Converging lens can also be known as convex and diverging can also be known as concave. I'm just going to be referring to them as converging and diverging. So converging lenses, what they do is they bring parallel rays and converge them to a point. So converge means come together or come to a point. So they converge at this point, and this point is known as the focal point. And the focal length is the length from the optical center, which is a line through the center of the lens to the focal point, and that is denoted by F. Diverging lens does the opposite of converging lens, so it takes parallel rays and it moves them away from a point. So the diverging means moving away. Two paths diverged in the woods, and I took the one less travelled. So diverging lens diverge as if coming from a point that is behind the lens, and that point is a virtual focus. So that's given also the same length, the focal length between the optical center and our focal point. Okay, so that's the virtual principal focus on the diverging lens and a real principal focus on the converging lens. So whenever we're doing equations and such with lenses, what will be given is an object, a screen, and a lens in the middle. So the object will produce rays which will then converge onto the screen. So whenever we actually draw these diagrams, which we'll come to in a minute, you'll often see the lines being parallel, and we just do say that the rays are parallel for simplicity. Okay, so the distance between the object and the screen is known as U, the object distance, and from the image that will form on the screen to the lens is known as V. I said the distance from the object to the screen. It's obviously the distance from the object to the optical center of the lens. So in a ray diagram, for a converging lens, rays look like this, with the arrows pointing up, okay? And that's just to sort of symbolize the shape, because I suppose it is a little bit like an arrow there at the top. Okay, so these lenses take one ray parallel from the object is in blue here, and it takes a ray parallel and then diverges through the principal focus, okay? So then the other ray will go straight through the optical center, which is right in the middle where our ruler line, for want of a better word, and the optical center of the lens will meet. Okay, so a line goes straight through that. So whenever these two lines meet, they'll form an image that is in focus. Okay, so images would be formed here, but they would be out of focus. Okay, if you had your screen there, and you can sort of think you would have to move if you're looking through a telescope or through a camera. You have to sometimes let it adjust and let it focus. Okay, and that is how you produce an image. So here the image is known as inverted. It is magnified, and it is real. Okay, so real just means it can be produced on a screen. Okay, this object is erect or upright, and it is also real. Okay, if you can't produce the image, if you wouldn't be able to project the image onto a screen, then it's known as a virtual image. Okay. Diverging rays, we draw them similarly. But so we've got this line always, which goes through the optical center without deviation. Okay. Then we've got a diverging lens, so the lens still travels parallel from the top of the object and then diverges as if it came straight from our focal point. Okay, and where these two lines cross is where we get our image. So this image here would be known as diminished, virtual, and erect. Okay, so then the lens equation is 1 over the object plus 1 over the image is equal to 1 over the focus. So this is focal length, image length, and object length. Okay, magnification is just the image height over the object height. It can also be the image distance over the object distance, because the height of the image is proportional to how far away it is from the lens. And then the power of a lens is measured in per meters or diopters, and it is 1 over the focal point. So for a diverging lens, this value is negative, and for a converging lens, it's positive. Okay, so in your eyes, you have muscles I think they're called radial muscles or ciliary muscles or something like that. And what they do is they take parallel rays and they will move the lens so that it converges the rays from a far point into the back of your eye, so that it hits your retina and goes through your optical nerve, and your brain can transform it into readable signals. If an object is close, it will converge the image onto the back of your eye, and it will get thicker and more powerful whenever it does so. So that's how a healthy eye should look. So if you don't need glasses, this is how your eye operates, okay? If, like me, you're short-sighted, so you will have myopia, what your lens does is it over-focuses the image from a far point. Okay, so I can still see near things, so that's why I'm short-sighted. So it over-focuses the image from the far points. This either means that the lens itself is too thick or the muscles are too strong. So they're over-focused, so you're getting a blurred image at the back of the optical nerve. The way to fix this is just to get a lens that diverges the far point image ever so slightly. So then whenever your lens converges the image, it'll bring it to a point in focus on the back of your retina. The opposite of nearsighted is farsighted, where you can see things that are far away, but you can't see things that are near. And this is hypermetropia, okay? So what this does is it doesn't focus the beams enough, okay? So it'll focus them to a point that is beyond the retina. So at the back of the eyeball here, we can see that this is clearly not into a point, so it's not focused enough, okay? The way that this the fix for this is to get glasses that have converging lenses that will then converge, do a bit of the convergence for you, if you like, so that the lens in your eye is able to converge it into a point. So this happens whenever either your lens is too thin or the muscles aren't as strong. So it often happens in people as they get older because their muscles relax and weaken. Okay, thank you very much. That is lenses.